Hello, everybody. Thanks for joining. I'm Jamil Ellis, your host for today. Today we're going to be talking about it's going to be AI 101, what every climate org should know about energy and water impacts. And we are going to get started in a moment. Um, I have a couple housekeeping rules. Yeah, please everyone stay on mute unless you're invited to speak. The session is being recorded. And if you can, add your name and org to the chat. And if you have any questions, please put those in the chat as well. As I said, I'm Jamil Ellis, CEO of Unified Ground. Our mission is to use technology to empower climate-focused community-based organizations. In that technology includes AI. Um, One of our main projects initiatives is AI Empower. And AI Empower is our flagship initiative. It's a live lab. It's an AI tool set. We co-designed it with a bunch of frontline CBO partners, and it seeks to use um, the technology potential of the generative AI to empower frontline communities. It's got climate. It will have climate and place-specific AI tools, training, AI policies, and use cases for organizations to grow from. And naturally, you can tell that what should be uh, that climate organizations are care about the climate, and so the footprint of the energy and water footprint, understanding is a big deal. It's not an abstract thing. We know the impact of climate change bears heavy impact on communities of color, and so we and so uh, I thought this is an important conversation because we can't build climate resilience on the backs of these extractive technologies. And our work is we want to really make sure that organizations and communities know what the right questions are, set the right boundaries, and leverage AI like on the right terms. And so with that, um, I will do less talking for the rest of this and let my good friend and compatriot Karl talk to us about AI and what should we know. So turning it over to you, Karl. Go ahead.
I appreciate that. Yeah, thanks a lot, Jamil. I appreciate you having me on and talking through this today. It's such an interesting topic. I know you and I have had a lot of conversations about it, and it kind of hits near and dear because we're in the space. We feel it, this idea that we both want to have this positive take and contribute positively in the technology space, but then also dealing with the realities that AI in general um, is really having a major impact in sustainability measures. It's a big conversation, and where it's kind of like at odds with different policies that are being enacted, and companies are maybe speaking on two ends of the coin, two sides of the coin, where they they want to build their products, and they also want to make profit. They want to have the ability to build out sustainable products, but then also like they also want to generate revenue, and so there's um, conflicting avenues there. So, anyways, thank you. Yeah, I appreciate you having me on. My name is Karl Haviland. I run Haviland Software, and we build software products for companies in the energy environmental space um, that are AI powered, um, and we help them from front to back. And today's topic, I'm going to be sharing my screen if you wouldn't mind, is what every climate organization should know about energy and water impacts inside of the AI 101 technology space. Um, just want to say hello and thank you, Jamil, with Unified Ground, and myself, Haviland Software. You can visit us, both of our websites available. And so I'm just going to jump right into it. First main point, Jamil. The data centers that power our LLMs consume a lot of energy and water. And we've heard this narrative on LinkedIn. We've had conversations on the side with other people within the space, and everybody's interested in the questions, who does that impact? And more importantly, what can you do about it? Conceptually, it's hard to think about. When we think of how LLMs use energy and use water, it boils down to the data centers that power them. And there's a little bit of an abstraction. So you're going to have to bear with me here for a minute. We need to get a bigger picture. Each data center uses a massive amount of electricity and a massive amount of water. But if we were to put those into real terms, I'm going to pick on Google here, use it as an example. So this is just one major cloud provider. On average, per day, one hyperscale mega data center is going to use about 500,000 gallons per day. It's just a mind-blowing amount of water clean water nonetheless. So there's a desalination process that needs to happen, or you're drawing from fresh water in order to cool the data centers down so that the power, the heat exchange on those servers can keep them operational. And the industry uses this water use efficiency metric in order to evaluate the utility usage for between water and energy. And as described by Meta, which maintains this metric, the industry average is about 1.8 liters per kilowatt hour. That's a lot. When you think about it, these hyperscale data centers will use about 1.1 million kilowatt hours per day. So keep that in the back of your head. Um, as we move along, the data centers are spread out. So we have, not just one data center, but each cloud provider has, at least for Google, has like 100 around the world, about 80, I think, in the United States. And you can see these are where they're located. The Northwest, the Southwest, you have center of America, that is like Middle America, and many that are along the East Coast. But I want to bring your direction down here to the Southwest. And if you've ever been there, you know that it is perpetually in drought season. So what happens if you're extracting millions of gallons of water per day? Um, it's not good. And there's not a lot of great options that you can take on. Um, I I think uh it's a very destructive process here. It's like it's not they put it there because you need to have some fault tolerance. Um and you need to be able to process or divide these data centers and workloads across, but that's something that we need to talk about.
And I just, if you go back to that for 1 second, I
Yeah,
just
for sure.
want to, because we are picking on Google, but as we said before, this is like Google is just one. You have to think that Amazon has a bunch and Microsoft, OpenAI. There's like the posture is to race to build more of these among at on a scale. And that doesn't even count. That's just the major American players, right? So like multiply
Yeah.
that by everyone trying to do things around models, and so this, you've got to, it's a sliver of this gigantic amount that of energy and water use.
Yeah, for sure. I will say, like on the counterpoint, it should be noted that so the water replacement is a huge challenge. And so these companies are trying to use recycled water. Um, I think the the metric that AWS puts out for themselves is about they're at about 20% recycled water, and they've tried to increase that number. Um, but it is, I mean, it's a sliver of the total piece of the pie. It's much easier to get towards it's much easier to attack the energy in a sustainable way, I think, than attacking the water problem because the renewable technologies exist, they're accessible. AWS at least has a sustainability plan for attempting to become uh, carbon neutral over the next 20 years. Who knows if that actually is possible, but um, yeah, it's a huge challenge, especially for areas that simply just don't have water. If you keep extracting it, you there's just not a whole lot of options there. And so this is a great slide suggestion for thinking about how when we use our LLMs, the things that are being powered by these data centers, we divide it out into two different approaches. Or two different tasks. One is that these large models need training time, huge energy and water expenditures or allocation towards actually building the model versus prompting, which is when you type into ChatGPT and you either create funny images or you're updating or creating an email, revamping your resume. Each one of these prompts takes up a sliver of the total amount of energy, but it really adds up when you have millions and millions of prompts that are occurring per day. It ends up producing a large load on these data centers because like the energy and water used to power the data centers is actually running and serving up those models to the public. So you can kind of think of like about the training time where you're measuring it in days, weeks versus prompting, which happens in a few seconds and but millions of times. And so there's a summary here is like you can think of those like each large data center is using about half a million or those hyperscale ones using about 500,000 gallons of water per day. So you think about basically 25 large swimming pools just gone every day from each one of these and about 300,000 kilowatt hours per day or enough to power 10,000 homes every day. It's a lot of energy. It's like a massive amount. So the large problems when you invest, large investments are occurring and you're scaling these numbers up. These represent like one block, one tile on the board, and they're scattered around the board. Um, Many locations are in water scarce areas, especially like the Southwest, but that's just the United States. So we're not even thinking about like the rest of the world. Um, Prompting the models, they only use a small portion of resources, but training process is very resource intensive. And the one of the bigger problems here is that major providers are not disclosing the consumption of current models. The policies that are being put in place, suggested policies would end up deregulating this in order to go full bore into um, uh, it would effectively make regulation on AI development illegal, and it
Yeah,
seems like a really big
like they're
problem.
preventing it at the state level, basically. Um, it's just so it's 10,000 homes. We looked at this right before we started, and I was like, 10,000 homes, wow, a day for each of these. And you think about it stretched in some places where the grid is stretched um already.
Yeah,
And so uh it's uh it's a lot. Yeah, and I think on that non-disclosure like that opaqueness and the the posture that the government right now is about how to support these initiatives is just build, build, build.
Yeah.
It's like drill, baby, drill. Is the is has been the approach, and I think it's important to note that it doesn't need to be that way for all. If you're creating this, is not inherent to the technology; it's inherent to the
Yeah.
approach that we're doing here in the U.S. And I think that's always when I talk to organizations, I think that's always an important thing to talk about. It's like this is the model currently that's going on. Some of it we can control, and some of it we can't control too much because we don't know what's going on. But it's not inherent to the technology specifically, or and which is most useful. And you could do something about it. I know you're. I'll be quiet again and tell us what you're gonna go into like what people can actually do.
Yeah, that's a good point. It does seem I get caught up in this as well, where it does seem like, we're a small piece in the pie. Sometimes you think to yourself, maybe I'll just when it comes to like recycling, it's like it's that one piece of trash. You know what? I'll just throw it away. And it's like it has like a small impact. You think to yourself, like, what could I do? And those small things add up. So like the big point here is that the models, the modality, the prompts you choose all affect utility consumption. And so we ask ourselves, like, how do we make better choices across each one of these ideas? So the first thing that comes to mind is we can prompt smaller. When you're building out software, this is a thing that we think about. Are we classifying versus analyzing? I'll show an example here in a sec. Are you asking ChatGPT to limit its response length? This is a really common thing. We just kind of let the response go unfettered. And the longer it processes, the more energy and resources it's consuming. When in reality, one paragraph could probably suffice. We may not need seven or three. Uh, Being able to bring those responses down, and truly that's where it comes down to, is allows or can reduce like the energy expenditure. Um, and then this last one is reducing the reasoning chains. This just means as agentic AI has expanded out, they have to go through reasoning stops where it's thinking through your question. And when we reduce the reasoning chains, we don't let it kind of run off in for as long as it would like to. We give it a little bit of a hard stop. And we say, like, all right, we want you to reach an answer by this point. That ends up reducing the number of times it's going out to the LLM. It reduces the amount of processing power needed to handle that inference. And so what we're doing is we're prompting smaller. In all these capacities, we're thinking about just reducing the amount that we're leveraging the LLM, but still getting the answer that we need. So I gave an example here. Actually, I used ChatGPT to help me out with this. This is the classify versus analyzed. When I mention those two terms, it's not always obvious. It's not obvious to maybe like a layperson what that means. But the example here, we asked ChatGPT to review this statement, and we ask it both to classify it. So one prompt is to classify that review. The other one is to analyze it. And so as you can see, the review is, despite a slow start, the film eventually finds its rhythm. Strong performances and beautiful cinematography redeem what could have been a forgettable experience. When we think of classification, we're expecting a one-word answer. We give it a few things to choose from. Is it positive, neutral, or negative? Oh, it's positive. Simple. Not a very long response, not a very long prompt. Um, it's a lot smaller footprint there. But when we ask it to analyze, it's got to go through more, it's got to go through a lot more processing in order to get to reasonable answers. In this case, we're saying limit your response to 3 bullet points and analyze this movie review and explain it. And so the response we have here is three different bullets. It's a lot longer. Um, and in order to arrive at that, there's more that you need to think about. If I were to ask you this yourself, you would probably take you a lot longer uh, to come up with an analysis on the movie review as it would be to just say, all right, pick one of these three and just tell me which one it is, positive, neutral, or negative. One is more broad, one is very specific. So it kind of gives you that mental image. But then we have a lot of different use cases where we actually use the model. So not even like just the prompting, but when we're building out software, we need to choose between models. In general, smaller models need less resources. Duh. It's like it's smaller. It doesn't need as much to run. Uh, Depending on what you're doing, there are trade-offs between the cost, the accuracy, the reasoning, the knowledge, the speed. If you don't need deep analysis of what's being written, you can use smaller models that give you a more concise, direct answer, maybe like limits back and forth. These are perfectly good use cases. You don't need the most powerful model on Earth to power an FAQ back and forth, or maybe even just to, like I was saying before, like classify um, a paragraph. It may be perfectly useful for you to use a smaller model to do those. So what I did was, this is directly from Anthropic's website. They provide a little matrix for how you choose which model. And this gives you an example here. Claude Opus is highly intelligent. This can back multi-agent framework. It's a lot bigger. It's more complex. Or Claude Sonnet, which is more of a balance between intelligence and speed. It's going to be a little bit smaller, a little bit faster to work with, but it's not going to be able to, if you use it to back your agents, those agents are probably going to be led astray. Those agents are executing tools, they're actually performing functions. You may not want a Sonnet-backed model to handle those requests. And then there's Haiku, which is a lot much, much smaller. It's meant for that basic back and forth. It's meant to be fast and straightforward. A similar thing can be done for OpenAI. I should have put another slide in here. You have like 4.0 or 4.0 mini. Mini is going to be that smaller model that's more direct, and it's going to be like similar to your Sonnet. Whereas like 4.0, you'd be able to like use it it's multimodal in a like an agent framework. Um, It'd be for a variety of different capacities, very powerful.
I didn't, this is so helpful because I just look up at that model thing in the corner in ChatGPT. I'm like, what are all, there's like five different models. It's like, does it matter?
Right.
It does. And it's sometimes hard to, because they don't really tell you this, in terms of energy use, in terms of like what the potential impact is and to start thinking on it. So this is super helpful.
Yeah. I appreciate that. That's a really good point. There's a big problem at the moment with these large model builders and not releasing or not disclosing what their energy and water usage is. Later on down the line, I'm gonna provide that link to the AI energy score from Hugging Face, and the people running that have been kind of up in arms at these major providers not really working with them to disclose that information, making it open source. Really big problem there. Well. I'm sure you'll like this one, Jamil. The avoid unnecessary prompting. This is kind of the third point. All those meaningless images that people are making, they are a lot more energy intensive than just like the simple prompting. With different modalities have different energy and water consumption, and um, the most common used are text, which you're editing an email, editing a document, or classifying, versus creating or generating images based on a textual edit, or even video for that matter. It's like really large artifact of data relative to text, which is a lot smaller. But then also, if you're building applications, I've found that you can circumvent the LLM in a lot of different cases. You may not necessarily need the agent or the application to go to the LLM at all. In a lot of cases, a more direct programmatic solution is perfectly acceptable, especially if you're going for speed. And um, and I think it's a point that maybe gets missed in a lot of tech teams, that we build AI integrated software, so everything must be AI integrated, and that may not necessarily be true. In fact, it may be a lot faster and more pragmatic and better for the team if they didn't. Uh, when we get a response from an LLM, it's non-deterministic. We don't really know what's going to come back. We're allowing the LLM to make a choice for us or provide whatever it thinks. So a more direct a more direct algorithmic path sometimes allows you to take control over situations, and in a much faster way, a much more cost-effective way than going at the LLM, and get the benefit of using less energy and water. So the last one here, I have a few tools and projects that are out there that you can use. If Code Carbon, for those that don't know, it's a Python framework that you can put into your code, and it gives you information about the energy usage based on some data on what servers you're using, and um, you'll be able to generate like really good metrics there. The second one is the Hugging Face AI Energy Score, which uses Code Carbon for its benchmarking. And the AI Energy Score takes different models, and what it does is it gives a star rating based on the energy and carbon usage, but energy usage per inference. And they go across different modalities, meaning like text or image generation, and then classifies different groups of models in how many GPUs they use, or whether it's like multi-server or multi-cluster. So really cool project that's being developed out by Hugging Face. Last but not least, I thought this was cool, the AWS like carbon footprint tool, which gives you insights into your cloud consumption, your cloud usage. It's meant to be attached to their sustainability goals. I think it's really nice, like having something that discloses or expands out, really breaks down what you're using as a user, so you can make some decisions on that. So I think that's interesting. And if you want to get the presentation, bring it up online. We have the QR code here. You can go to our LinkedIn page. Um, and that's it.
Yeah. Well, thank you, Carl. I think it's really I thought this was an important thing to have out there and to have this conversation. Because, as I said, I've talked to very climate oriented folks about and they are concerned at the same time they would make picture everyone was making pictures of themselves as Muppets. And
Yeah.
I was like, no, no, that would be the category of things you might want to avoid if there's a meme thing going on that involves you using AI and you want to use it as a toy, that is not a climate friendly action.
Yeah, for sure. Do you think
And
that like do you think that the investment in AI, so these data centers are growing and
yep.
these products are there are products coming to market that are using AI to generate those products and so we need the investment in the data centers to power AI to power the product development. Do you think pulling back on maybe some of like the renewable investment is going to really hurt our ability to help update the grid or power the grid or power these data centers in a way that might be more carbon producing friendly?
Yeah, I think the step away from renewables is definitely going to hurt our ability to with all these productions. That's why I really do think not only do I think it's about smaller models, but as we look to move AI and power forward, we also just looking at being able to power models off renewable energy, smaller models off
Mhm.
renewable energy, uh, that don't depend on data centers. Is like how can we create more sustainable ecosystems that are low energy and low water? And I think that's something that um, especially in this environment that, while it's always a balance. I think you use some of the tools that are out there, but we do need to be looking to that future where we are everything around it is more sustainable. It's not based on a data center out in the desert.
Yeah,
And so I think yeah, where it's I think that a lot of what's going on right now, the creative destruction of I was just reading about the DOE cutting billions from a lot of the renewable energy and mitigation plans. And I think that means that we have to look for new ways to have just sustainable, complete ecosystems that are community based has to be part of it. But I think for the first step is all the stuff that we've been talking about today is just to ask the right, being able to understand the basics and know the right questions to ask. I mean, the very obvious, the one you mentioned about sometimes there's a direct approach. I was in a tech meeting the other day, and it was like a very like, yes, we could get AI to filter everything here, but and figure out the file names and everything, but we could also just write some code to do it. We
yeah,
would know what's going on, and it wouldn't use any energy. So and so there's a I want to stress that for the coders out there, and as you're working with people, like there sometimes it's such a good point that sometimes AI just not the answer.
yeah. You
There's
could that's funny. It's like maybe that one or two LLM queries to write the code is worth the,
yes.
the several thousand queries that might manifest if you inject it.
If you injected LM, and that's like
Yeah,
that is a great um you're better off, that's exactly right, you're better off writing the code to do it correctly.
yeah.
And I think that that's something for the coders and tech folk out there, if you're talking to a tech folk and you want to keep it in mind, I
Hmm.
think it is a concept that you can communicate to someone that uses technology, that even it may be faster to do it the LLM way, but maybe um but doing it direct is it has a less climate impact and gets you like gives you more certainty.
Yeah,
Um
yeah.
so um want to thank everyone for joining today. Please join in the LinkedIn. We're gonna pause for a second before we do question and answer. And I'm gonna pause the recording so we get a clean recording for everyone who wants to see the presentation. We'll follow up. Don't worry, with some of the questions that folks asked, and we'll answer them on the LinkedIn page. So want to thank everyone for joining us today. I hope everyone has a bunch of fun Tech Week things going on. And I think that's it. Any last words, Carl? Are we good?
I think we're pretty good.
Awesome.
Prompt small.
Prompt small.
Prompt small. Don't you don't need that funny image today.
No Muppet images.
Yeah, no more images.